The velocity of a particle moving in a curvilinear path varies with time as this. This is how the velocity is varying with time. Given. At the end of t is equals to 1 second, we have to find the value of tangential acceleration. At the end of t is equals to 1 second, we have to find the tangential acceleration. Well, we will talk about tangential acceleration. But first of all, tell me, can you find the actual total acceleration of the particle? Well, we can, because velocity is given as a function of time. If we differentiate velocity vector with time, dv vector by dt, this gives us a vector, acceleration vector. And this is coming out to be 4t I cap plus 3t square j cap, isn't it? Now, once we have the total acceleration vector, it is very easy to find out the tangential acceleration. Now, let me explain you a bit. Suppose there is a beautiful curve and the particle is at this point. The velocity of the particle is like this. It is tangent to the curve, right? This is the velocity vector. Now, let me just talk about the centripetal acceleration AC and the tangential acceleration AT. As we can see, the velocity vector and the tangential vector are along the same line, and the centripetal acceleration is perpendicular to this line. Now, what is the total acceleration of the particle? As we can see, the total acceleration would look like this. The total acceleration is just the resultant of AC and AT. The centripetal acceleration and the tangential acceleration, if we add them, we get the total acceleration of the particle. Now, what do we know? We know how does the total acceleration varies with time. At t is equals to 1 second, we know the total acceleration of the particle is 4i cap plus 3j cap. We know this total acceleration. So we know what is this total acceleration. And what do we have to find out? We have to find out what is the value of AT. We have to find out the tangential acceleration. Or let me just say, if this angle between the velocity and the total acceleration is theta, we have to find AT, which is A cos of theta. So we have to find what is A cos theta. Now, can we find this? Yes, we can, because we know velocity as a function of time. Now, what is the velocity at t is equals to 1 second? As we can see, the velocity vector is this, and at t is equals to 1 second, velocity vector is 2i cap plus 1j cap. This is the velocity vector at t is equals to 1 second. Now, we know velocity vector and we know acceleration vector. We have to find out what is A cos of theta. Well, it is very easy to find out. I will give you a hint. Do you know what is the dot product between A vector and V vector? Do you know the dot product? Yes. Dot product is magnitude of A, magnitude of V, the velocity, and cos of theta. This is the dot product. And what do we have to find out? We have to find out A cos theta, isn't it? So A cos theta can be written as A vector dot V vector divided by magnitude of V, isn't it? Sometimes some people used to write in style. They write it like this: A vector dot V cap, which is the unit vector along the direction of velocity vector. Some people write it like this, but we will use the first formula: A vector dot V vector divided by magnitude of V. Now, what do we know? We know A vector and we also know V vector. So we can find the dot product, right? So A vector dot V vector, this dot product is coming out to be 4 times 2, which is 8, plus 3 times 1, which is 3. And this is 8 plus 3, which is 11. Now, dot product is known. Dot product is 11. We have to find out the magnitude of the velocity. Now, the velocity at t is equals to 1 second was 2 I cap plus j cap. The magnitude of the velocity, well, this is whole under root of 2 square plus 1 square. And this is nothing but under root 5. Alright. So, we know what is the magnitude, which is under root 5. Now, a cos theta comes out to be 11 divided by root 5, and a cos theta is nothing but tangential acceleration at. Can you see that? Alright. So, what is the answer? Answer is 11 by root 5. This is the magnitude of tangential acceleration. And let us find out, yes, option B, 11 by root 5 is the right answer for our question. An aircraft executes a horizontal circular loop of radius 2 kilometers with a speed of 900 kilometers per hour. So here is our aircraft and it is executing a horizontal circular loop, and the speed of this aircraft is already given. It is 900 kilometers per hour. So V is known and radius is also known. It is 2 kilometers. The centripetal acceleration is x times the acceleration due to gravity. So centripetal acceleration is given to be xg, or we can write it as 10x. What is the value of x? So we have to find out what is x. Now, question is straightforward. We know what is velocity. We know what is radius. Can we find AC? Yes, we can. What is the formula? AC is equals to V square by R. Simple. Now, we have to write velocity in terms of meter per second first. Velocity was 900 kilometer per hour. 900 kilometer per hour. Now, kilometer means 1000 meter. So, let's write 1000 meters over here. What is 1 hour? 1 hour is 3600 seconds. So, let's write 3600 seconds over here. This is giving us 9 4s are 36 and 2 zeros cancel out over here, and we are getting V is equals to 250 meter per second. Wow, great. We know the velocity in meter per second now. So let's put it over here. 250 whole square. We have to divide it by R. Now R is 2 kilometers. This can be written as 2000 meters. Alright. Now when we solve it, we are getting 3.125. And we can see that option B is the right answer for our question. With what acceleration A should the box, by box we mean the bigger box. Can you see the bigger box? Right. So with what acceleration A should the box in the figure descend so that the block of mass capital M exerts mg by 4 on the floor of that box? So here we have a big box and we will call this big box as our elevator. And there is a floor of this elevator. This is the green floor. Alright. Now, it is said that this elevator is undergoing some acceleration. And we have to find what is the value of this acceleration if the block of mass capital M exerts a force mg by 4 on the floor of this bigger box or the elevator. Now, if the force exerted on the floor is mg by 4, the floor will exert an equal and opposite force. So the force exerted by the floor on the block is also mg by 4, right? And we will call it normal reaction. Now, if the normal reaction on the block is mg by 4, can we calculate what is the common acceleration of this elevator and the block of mass capital M. Can we find this acceleration? This is the question. You will say, well, yes, we can. We can see this problem in ground frame of reference. If we are standing on the ground, we will draw the free body diagram of this block like this. We will say the block has some acceleration A in the downward direction with respect to ground. We are standing on the ground, so the acceleration is A. Alright, there is mg in the downward direction and there is some normal reaction in the upward direction. Normal reaction is equal to mg by 4. Alright, now what is the equation? The equation goes like this. mg minus mg by 4 is equals to ma, mass times acceleration. Right, this is the equation from Newton's second law. And the acceleration from it is coming out to be 3g by 4. Can you see the right option? Yes, option C is the right answer for our question. Now before we go, I will tell you one more trick to solve this problem. The other way goes like this. We won't stand on the ground. In fact, we will stand inside the lift. Now, if we are standing inside this lift, we will see that the block of mass capital M is not moving at all with respect to us. This block stays at rest without any acceleration with respect to us. Now, what are the forces acting on this block? One force is capital mg in the downward direction and another force is normal reaction. But can we apply the Newton's law? No, we cannot, because we are in non-inertial reference frame. Now, to get an equation, we will take the help of pseudo force. The pseudo force on the block of mass capital M will be in the opposite direction to the acceleration of our reference frame. So, acceleration of our reference frame was in downward direction. We will apply pseudo force in upward direction and the value of pseudo force is capital M times A. Now we can write the equation. The equation goes like this. mg is equals to mg by 4 plus ma. Can you see it? Yes. And this equation also gives us the same acceleration. Yes. So, option C will be the right answer for our question. An insect. I can see the spider right now. An insect crawls up a hemispherical surface very slowly. The coefficient of friction between the insect and the surface is 1 by 3. So mu is equals to 1 by 3. If the line joining the center of the hemispherical surface to the insect makes an angle alpha with the vertical, the maximum possible value of alpha is given by. So we have to tell what is the maximum possible value of alpha. This is the angle alpha. What can be the maximum possible value of this angle? Now, you can see that the insect can crawl up to a certain height. It cannot go beyond that height. And we have to tell what is the maximum value of alpha. Now, let us say the insect is at its peak height. At this peak height, the value of friction is also at its peak, right? So friction is at its peak. The friction cannot go beyond this value. The insect can also not climb beyond this particular height. Now, we can say that at this particular instance, the tangent to the surface is like this. It is making an angle alpha with the horizontal, right? We can see that. Now, if this angle is alpha, we can say that mg is acting in downward direction like this, and the angle of mg with this line is also alpha. Can we say that? Right. Now, there is a force on the spider. One component of mg is mg cos alpha, and the other component of mg is down the incline or down this imaginary tangent as mg sin alpha. Can we see that? Right. Now, the friction force is at its peak value. And what is the peak value of friction? Come on, tell me the peak value of friction. It is normal reaction times mu. So, friction is normal reaction times mu. Okay. Now, normal reaction over here, we can see is mg cos alpha, right? So, normal reaction is mg cos of alpha. What is the value of mu? Well, in the question, mu was given to be 1 by 3. We will put the value later on. So mg cos alpha times mu is the force up the incline, right? So we can write mg cos alpha times mu, the force up the incline, must be equal to the force down the incline, because at this position the insect will not slip. It will slip after that. If it tries to climb higher up, then it will slip, but at this particular height it is stable. So this is equal to mg sine alpha, right? Now this means that mu is equals to tan alpha, right? Mu is equals to tan alpha. Alpha is tan inverse mu. We got the angle alpha, the maximum possible angle alpha. And in the question it was said that mu was 1 by 3. So we can use another formula. We can say that cot alpha is equal to 1 by mu, and mu was 1 by 3. Therefore cot alpha in our case will be equal to 3. Cot alpha is equals to 3. And let us see the option. We can see that option A is exactly the right answer for our question. A block is capped on rough inclined plane as shown in the figure. It remains at rest up to a maximum force of 2 Newton down the inclined plane. So, if we apply 2 Newton down the inclined plane, the block will stay at rest. If a force is higher than 2 Newton is applied down the inclined plane, then there is slipping. This is the question up to now. The maximum external force up the inclined plane such that the block does not move is 10 Newton. So we can apply 10 Newton up the inclined plane and the block will still not move. The coefficient of static friction between the block and the plane is, we have to tell what is the coefficient of static friction, mu. What is the value of mu? This is the question. Now, we have two situations in the question. First situation, we are applying 2 Newton down the inclined plane, the block does not move. If the force higher than 2 Newton is applied, there will be slipping. This means when 2 Newton was present, the friction force was at its peak value. It was preventing the block from slipping. The peak value of friction, by the way, what is the peak value of friction? You will say it is normal reaction times mu. Correct. Now here is normal reaction and we have to calculate what is the value of mu. Let us draw the complete free body diagram. Now when we divide mg into two parts, we can write one part down the incline is mg sine of 30 degree, isn't it? And the other part is mg cos of 30 degree, right? All right. Now let's look at the other situation. In the other situation, we are applying 10 Newton up the inclined plane and the block is still not moving. If a force higher than 10 Newton is applied, then there is slipping. This means friction force is at its peak value when 10 Newton is applied up the inclined plane. And the friction force is down the incline this time. It opposes the 10 Newton. The other forces is normal reaction and mg. Mg, you can see that can be broken into two parts. One is mg sine of 30 degree. Other part is mg cos of 30 degree. Right? Right. Now, acceleration is 0 in both the cases and friction force is at its peak value, that is normal reaction times mu. Now, let's talk about the first equation, the equation from our first free body diagram. The equation goes like this: 2 Newton plus mg sine of 30 degree. This entire thing is equal to total up the incline force, which is friction force, normal reaction times mu. Normal reaction is mg cos of 30 degree and mu we have to calculate. This is our first equation. Now let's talk about the second equation. The second equation we can see is from the second free body diagram. The down the inclined forces include mg sine of 30 degree plus friction force, which is normal reaction times mu, and this is equal to total up the inclined force, which is 10 Newton. Correct. This is our equation 2. Now what we will do? We will add the two equations. When we add the two equations, we will get something like this. We get 2 mg sine of 30 degree is equal to 8. Sine 30, what is sine 30? Sine 30 is half, so 2 gets cancelled out. 1, 2 in the numerator cancels out 1, 2 in the denominator. And we get what is the value of mass. M comes out to be 8 by 10, which is 0.8 kg. Well done. We got what is the mass. But what was asked in the question? The question was asking us what is the value of mu. So let's go back and calculate what is the value of mu. Now how we will do that? We will just place the value of mass in any of the equation. Or we can just subtract the two equation. Mg sine 30 will get cancelled out and we are getting 12 is equals to 2 mg cos 30 degree times mu. Let's put the value of m and get the value of mu. So we are getting mu is equals to 3 by 2 root 3. And this means root 3 by 2 is the correct answer for our question. Mu must be equal to root 3 by 2. Let us see. Option A is the correct answer for our question.